Hello everyone and welcome to another one of my videos, and in this video I will be showing these two monitors that I modified to work off of 5 volts. And as you will see in a moment, I will be plugging this in to a power bank just to show you that it does work. And there we go. I don't know if you can see that yet. All powered by a power bank. No. Yeah, and I'm gonna take it apart. And they have lots of clips in them, so. Okay, so let's open. So let me get the original power supply from it that I kept just to make this video, I guess. This power supply is from this bigger monitor, while this smaller one I think is, yeah, you can see the power connector is also faced up like this case, so yeah. This whole shield is kind of just stuck with tape, and that's kind of what it was when I first opened it up. Just put some electrical tape. And so you can see how terrible I did this. So, this board, yeah, that is the original board from this thing. I see the screw holes match. So this is kind of originally how it looked. Yeah, you can also tell I desoldered already some parts off of this board, but yeah, that's also why I keep these boards. So what did I do here? If you take a look at the power supply board, let me get that zoomed in. I don't know if you can notice. Yeah, you can see it. This says pin 1 to 3 is 5 volts, 4 to 5 is ground, and 6 is on off. And so those are the 3 important pins. There's also a BRI, I don't know what that is. Oh, brightness probably. So probably just a PWM signal that's sent to this to change the brightness. And you have power saving, which I guess it just tells the power supply to go into power saving mode or something like that, or whatever. Yeah, so all that's important is the 5 volt pin, the ground pin, and the what was it? I already forgot. The on-off pin, which is used to turn the backlights on and off. And so each monitor is probably going to be different. Some are probably the pin's going to be outputting voltage for the backlights to be off, and some might have that pin pulled low to actually turn the backlights on. Oh, I really feel like I'm gonna break it. Okay, I'll just glue that back later, I guess. I'll solder it all and do everything again. Okay. Yeah, that was hot glue. I just did the thing. So, yeah, that was hot glue, that potentiometer to change the brightness was just hot glued to the case. At least I didn't do that for this big monitor. Okay, it's off. Yeah, I don't want to break those cables here. I would not recommend pulling it this way, because that already starts to bend them. And if you break those off, good luck gluing them back on, because they're not soldered, they're glued with some special glue, I'm sure. Not just any glue, so yeah, You know what? I'm gonna have to take off more than I thought I would. Have to take off. I would not recommend, if you do not want to break your panel, then do not do what I'm doing. Holding it by this, you don't want to do that. And this part, you want to make, you know what, this is acting like a mirror. Did I break it or not? I don't know. Did I do this? Yeah, I probably broke. Oh, they work. Oh, they work. Oh, and you can now see this area right here. This is where I have an LED I probably cracked while pushing on there. So yeah, that's the hard part about doing this. To modify it to work on 5 volts is, if you use the type of LEDs I used, yeah, that will happen. You can also kind of tell, you kind of see some bright spots where the LEDs actually are, and those are unfortunately visible on the actual screen. So that's a downside to the way I modify these monitors to work on 5 volts. And you can see my dead LEDs. It's only one of those LEDs that broke, and that's what's causing that. If I push, maybe I'll get it to do anything. This is a piece of white plastic, and I'm sure it's just used to reflect the light that comes from like this side, and it just reflects it back at the LCD, so that way you don't lose any light. And you can see the dead pixels, I'm sure. Here, let me check the camera. Yeah, you can see that. And if I push, so these lamps, I don't know which one's the right size, because these all came from different monitors. They also have mercury in them, so I don't want to break them. Even though I did break some, because it's kind of hard not to. Okay, so this one probably, there we go. Yeah, if you drop this, it will just, yeah, go everywhere. So this is, you'll find 2 of these in here usually. Because they use high voltage, they kind of have some rubber on both sides, and I'm guessing that's to insulate them from this whole thing that holds them, which is aluminum, it feels like. It also has some more white tape, I guess, on it, or paint, I don't know. Some white plastic stuff, I guess. Anyways, that's of course to reflect it. And if you do this and you only do one side with the LEDs, and you take this and you just don't put it back, you're gonna be losing light, because that light will come, oops. Okay, I got it off. You can see the dead LEDs. One of those are cracked in half. Let me see if the camera can see those. Yeah. So you can see this row right here, it died. Let me see if I can maybe push an LED here. I took these LEDs out of the monitor I dropped and broke. Yeah. Normally these LEDs were wired like all in series, and so you had to have like 30 volts or something like that to light them. And so I just unsoldered them and rewired them. I used some enameled wire, like from transformers or whatever. And that's kind of just, I just fill this area with hot glue. I heat this whole thing up, and I kind of just smush this to this piece of acrylic, I guess. Yeah, and I just smush it. And hope you don't crack any LEDs. Okay. I don't know why that's not working. You know. Okay, so these driver boards, they always all say 5 volts. So if you take a look, hold on. If you take a look right here, let me focus the camera. You can see 5 volts. Yeah, I see a 5.1 volt. I don't know what that is. It's not even connected anyways. Probably 5 volts would work there anyways if it was connected. Yeah. So, all monitors seem to just be powered by 5 volts. I mean, there are some 12 volt ones, I'm sure, but these, at least so far, these 2 monitors, they are like that. So I'm sure many monitors are like that. If you noticed, both of these boards, they're both marked which pins are which. Not all the monitors are gonna be like that. Some you're gonna have to find which pin's which. I guess I can kind of show you how each pin should look so you can find them. Yeah, so this is kind of how the driver board looks, if you want to see it up close. Okay, so I'm just gonna plug this in. I'm just discharging the cable, that way if there's some static that somehow got in the probe, that way it doesn't, you know, hurt the oscilloscope. Yeah, one thing I do want to show you is, okay, so I'm gonna plug that into the calibrating port. Okay, so you got that square wave. So watch this. See the square wave on the screen? Okay, so this turned on. I don't know if you can notice anything. I have my screen here showing what that video with the oscilloscope showing. Take a look what happens when I unplug the ground pin from the probe, like from there. You see those, you know, some weird lines. I'm just gonna call them weird lines. Yeah, so that is noise coming from this monitor because I just turned this monitor on. Look at that. If I turn it off, it's gone. That's a very huge, I guess I could say, mistake I made while making this monitor. The driver is just so noisy, and that is what this toroid's for. It's supposed to get rid of that noise, but it doesn't. So, okay. Let me get back to this smaller monitor before I spoil everything about this big monitor. Yeah. Unplug that. That was so hard to plug in for some reason. Okay, let me get that in. So that turned on. What I want to show you is just all the pins. So I should have, let's see, that is a, let me get a, okay, I'm back. So if you want to identify which pins are which on the power supply board for the monitor, the first thing you definitely need to do is make sure that the brightness of the monitor is like 50%. It can't be 100 or 0 if that's possible. I don't think any monitor has 0%, it's like as an option. Anyways, here it is 56%, so that's good enough. It can be 70%, doesn't matter, but I would go 50 just so it's in the middle. Okay, so what I did is I disconnected this monitor from power while it was on, but this is only for my monitor so that when I plug it in again, I don't have to click the power button to turn it on. It'll instead automatically power on. If you don't know where the ground is, you're not going to know where any pin is. So I would turn the multimeter to continuity, and now I would connect it to something that I know is ground. And what I know is ground, and what I know is probably the same on every monitor, is this whole shield that this whole motherboard screwed onto. it's all ground, I'm pretty sure, and I'm pretty sure like every monitor is the same in that way. So I put the ground probe of the multimeter to connect it to this shield, and now we simply find which pins are ground on here. So that one you could hear, that one is connected. This one's also connected. So once you know it's ground, now you can search for the power. Now you need to make sure that the monitor is always having its LCD like showing something, because if it turns off, it may go into power saving mode, and the power supply, the original board for this, may actually be turning that 5-volt power off, or at least. So what you need to do now is find a pin that is around 5 volts. So you can see this pin is 4.7, and I measured this one too. It's also about 4.7. Okay, I'm measuring it. You see 0 volts. And now that the backlight's turned on, you see 3. Okay, so I have this oscilloscope set to DC. And like, let's do 0.5 volts per division. So I'm gonna borrow a probe from my multimeter just to make this easier. Yeah, it's about touching. Okay, so next you're looking for a PWM signal or an I2C signal, which would be probably the worst. So I'm testing from the back because those pins are the last ones that I haven't checked. The pin with no voltage is pretty much like no voltage, it's a few millivolts. Next pin seems to get out of the scale, so I need to change that. Maybe like to 1 volt division, there we go. So checking that next pin, I just see a constant voltage, which was like 2.4, I remember. Next pin, and look at that. You see this? So this is the pin next to the brightness controlling pin. This pin right here is outputting a PWM. Let me get those. There are like some slots or whatever that this diffusing plastic goes in. Okay, it's in there, finally. Look how many, I don't know if you can see it, but there are fingerprints on here. Okay, it doesn't matter. You can't really see those on the actual LCD, which is a good thing. I mean, if you look closely, I bet you would. Not really, actually. The light gets so diffused that you probably wouldn't see it. Let me just make sure that's good. Yeah, it looks good. So you see how the LCD is currently off. Okay, I don't know, okay. I did a right click right there. You can kind of notice a darker spot there. That's where the dead LEDs are. Anyways. Yay, you get to see all my video editing here. That's not where this is supposed to go. Hold on just a second. I am using Windows 7. Be happy. works, even though everyone has Windows 11 now. There we go. It's all quickly set up. Didn't mess anything up. Good. You can see how this one works. Here, let me do like a task manager. You can notice these brighter and darker spots. That's where the LEDs are. And guess what? I got used to that. Somebody else that would be using other monitors would, if they try to use my monitor, they'd go crazy.